Section 6.2 is writing and solving proportions. I can write and solve proportions. A proportion is an equation that states that two ratios are equal. So 2 over 3 is the same as 8 over 12. If we reduced 8 over 12 down, we'd get the same thing. So equivalent ratios here. If one of the numbers in a proportion is unknown, we can solve the proportion to find the unknown number. One way to solve a proportion is to use mental math to find an equivalent ratio. In example 1, we're going to solve the proportion. So if we look at 5 over 6 equals some number over 18, we're going to look and see if we can find a pattern or something that we can use to relate these two fractions. If I look, I can go from 6 to 18 by multiplying by 3. Whatever I do to the bottom, I know I can do to the top. So I can multiply that by 3 and get 15. So x is going to be 15. 15 over 18 is the same as 5 over 6. So, same idea down here. You go ahead and pause here and try these. So, to go from 7 to 21, because this is where my variable is, I can multiply by 3. Whatever I do to the bottom, I have to do on top. So x is going to be 6. 6 over 21 is the same as 2 over 7. Same idea here. My variable's here, so I'm going to move from my full fraction to the one that's missing. So it'll go from 8 to 32. I multiply by 4. Since I multiplied by 4 on the bottom, I can multiply by 4 on the top. And I get x to be 12. Here, we have to go from our full fraction to the one that has the variable. So here, how did I go from 10 to 2? Well, I divided by 5. So I have to do the same on top and divide by 5. And x is going to be 4. So be careful there. Make sure if we go from our full fraction to our fraction that's missing a piece, if we got smaller, make sure we got smaller on the top as well, or on the part that's missing. Here, I'm missing x, so I look at my full fraction. How do I go from 12 to 48? Times 4. So I have to do the same on top, times 4, and x is 24. Okay, so here we're looking for the patterns. What happened to change one fraction to the other? We can also use algebra. So we can use the same methods we use to solve equations to solve proportions that have a variable in the numerator. So if my x is in the numerator, I can look and see what's happening to my variable. Right now, it's being divided. It's divided by 12. And we get rid of division by multiplying. So I can multiply by 12 on both sides to get rid of my 12. And I get x equals, remember fractions we can write as over 1, and with fractions we multiply straight across. So I get 24 over 8, which simplifies to 3. Again, you can go ahead and pause here if you'd like, and try these. So, we can use algebra to solve. Make sure you show your work on these to make sure that I can see that you're using algebra. Right now, x is being divided by 25. We're trying to get x by itself. So to get rid of the division, I multiply by 25 on both sides. 25 times 2 is 50. 1 times 5 is 5. And that reduces to be 10. So x is going to be 10. Same idea here. X is being divided, so we get rid of it by multiplying. And I know that when you're looking at these guys, you might be thinking, well, I can see that by using patterns the same way that we did before. And that's fine, but sometimes there's going to be some that doesn't work on. So having this in your arsenal as another way to solve is helpful. I get, when I multiply here, 100 times 3 is 300, and 1 times 10 is 10. When I divide there and reduce, I get 30 is what x is going to equal. Same idea here, x is being divided by 9, so we get rid of it by multiplying. Whatever I do to one side, I've got to do to both. When I multiply here, I get 378. over 54. And when I divide those, I take 378 divided by 54 and get 7. So 7 over 9 is the same as 42 over 54. And again, we could have seen that by multiplying by 6, or dividing by 6, but we're trying to work with this process so that we can use it on things where it doesn't work. X is being divided by 4, so we're going to multiply by 4. When I multiply across, I get 52 over 2, and divide those, and we get 26. So again, it's being divided, we get rid of division by multiplying, and whatever we do to one side, we've got to do to both. We multiply fractions by multiplying straight across, numerator times numerator, denominator times denominator, and then simplifying. When we set up a proportion here, guys, there's different ways that we can do it. Consider the following problem. Yesterday, you rode your bike 18 miles in 2.5 hours. Today, you plan to ride your bike for 3.5 hours. If you ride at the same rate as yesterday, how far will you ride? If we look at the tables on page 276, they show two different ways that we can set up the information. In each table, X represents the number of miles you can ride in 3.5 hours, since that's what the problem's trying to find out. So it's important, guys, that we compare the same things. We can compare miles to miles. We can compare hours to hours. We can compare today to yesterday. It doesn't matter how we set them up as long as we're consistent. So if I put miles to hours in my first fraction, I have to do miles to hours in my second. If I do yesterday over today in my first fraction, I have to do yesterday over today. And if I do that, I still have to put miles with miles and hours with hours. Okay, they have to be comparable. Both ways to write proportions work, and it's important to make sure we use comparable ratios. We cannot write a proportion to compare miles to hours and hours to miles. These aren't the same thing. Okay, they have to be comparable. So if we put miles on top, we have to put miles on top. And if we put hours in the bottom, we have to put hours in the bottom. Okay, we could have done hours over miles, but we'd have had to do it in both. Each day, an elephant eats 5 pounds of food for every 100 pounds of its body weight. How much does a 9,300-pound elephant eat per day? So here the things we're comparing are pounds of food. So pounds of food to pounds of its body weight. So like pounds of elephant, how much the elephant weighs. And we can compare this to the one that we know, 5 pounds for 100 pounds of elephant equals, we don't know how much food, that's what we're looking for. How much does it eat per day? So we're looking for how many pounds of food. And we know the elephant weighs 9,300 pounds, and that's pounds of elephant here, or pounds of weight. So to solve this, we see our variables being divided, so we multiply by 9,300. Whatever we do to one side, we do to both. And again, it's very important that we keep them consistent. Since we're talking about food up top, we're talking about food up top. Since we're talking about elephants here, we talk about elephants here. When we multiply there, in our numerator, we're going to get 46,500 over 100. And when we divide, we get 465 pounds of food, which means I may need to rethink my plan to have a baby elephant. And that is all for section 6.2.